Hi everyone, so today we're going to do a tutorial in the Unity game engine. I'm using Unity 2018-1, but this code and project has been open and tested in Unity 5.6, Unity 2017. So it works agnostic of the editors. And basically this is going to be a tutorial on how to create a lightning effect in your game with crashing thunder and raindrops coming down. With splashes on the ground and accompanying sound effects. So you'll notice in my project, first off here, I use the tall window layout and I use the one column. So if this window layout in the GUI here looks unfamiliar to you, that's probably why. So I have a few things in my project here which are some particle effect examples that come from the Unity Asset Store. They're from Unity Technologies and free. I have a Flickering Light script, which is a script I did in a previous tutorial, and we're not really going to go through this script entirely in this tutorial because I have another tutorial for it, but the download links for both of the scripts we're going to create will be in the video description underneath this video, so you'll be able to just download those directly from Dropbox and you don't have to write anything. And then I have a couple of audio clips in here, a lightning crashing sound, which is annoyingly loud like that, and then another one for a little variety, and then a looping ambient rain sound. So the effect examples would be that you go to the Unity Asset Store tab over here and you would type in Unity Particle Pack. And it's this right here. And you can basically remove or delete all of the other stuff that comes, but it's really some nice high quality particles that obviously work in 2018, 2017, and they work in anything beyond this 5.5. But what we're looking for in this when we imported it were the water effects, most specifically the rain effect. And we're going to use that here in just a moment. So that's where these effects came from. You can import those directly into your empty project. This is an empty project that I have. As for the audio, I'm going to bring a Chrome tab over. And what I did was freesound.org has a lot of open source audio on it. Most of it is just minimal attribution required, like just credit the name of the author of this music or sound, and a lot of it is just Creative Commons where you don't really have to credit and you can use in commercial and all stuff like that. So you just go in here and type in rain or lightning and kind of find. That's a pretty good one. That's more like a rolling thunder. Well, that one sounds simulated, and it says it's simulated, so you just have to look through there and kind of find the sounds that you think work for you or whatever, and bring those into your project. We're going to create an array of these so you can have as many different types of lightning crashes as you like, but I used 2. So let's just get started on this. And so for lightning, we're going to assume that we have a violent thunderstorm going on in our project, and so the sky is dark, or it's nighttime, so the skies look very similar. And what we're going to do is just create a material, and we'll just call it sky, and it's going to be here where the standard tab is. It's going to be a type of skybox, and we'll just use the procedural. Now if you have your own cool 6-sided skybox with a dark, cloudy, rainy sky, no problem on that. So some of the settings that we want to do on this is we're not going to have a sun, right, because it's horrible weather and cloudy overcast sky. So we're going to go none and drag the sun size down to 0, and we're going to kind of thin out the atmosphere a little bit just to help it kind of darken up. And then we're going to go in here and we're going to make the sky tint pretty dark. We can go in there, let's make it light first, and then kind of take it to a kind of maybe a dark purplish blue hue. That kind of looks good. And then let's assume that the ground looks kind of wet and desaturated, and it's also dark because it's not being really illuminated by much. And we'll go dark with that. And so the exposure, we can kind of play with that value. I'd say maybe 0.5. This is going to be to taste how you really want that to look for your specific scene. The next thing we want to do is kind of go in our lighting tab here under Window, Lighting, go to the settings for the lighting, and then we will drag in that sky, and Unity is now using that horrible cloudy weather sky, or nighttime sky, whatever you want to look at that for. And one of the things I always usually do is under environment lighting, it's just more expensive to use that real-time sky box, so we just do a color, and then we go in there and just set the ambient, can kind of make it even a little more like of a purplish hue. And then that's fine. We can close that window out. So for the instances of this tutorial, let's just go to Game Object, 3D Object, and create a plane and kind of expand it out maybe 6 by 6. And it looks really bright, like there's a sunlight going on here, and we'll need to tweak our light here momentarily for that. We can just, for our own sanity, call this ground. And then what we'll want to do over here is just right click in the project window and go create material, and we'll call it ground. You can left mouse hold on it, drag and drop it onto the ground. And we'll just turn off the smoothness and metallic. We will click this little icon next to albedo, scroll down, and just assign this default checker. And then we'll tile it a little bit. This is just to give us kind of a ground we can see. And then I think we can leave that be. We don't really need to mess with the diffuse settings on it. So this light source that we have right here, I'm going to right click this left click this little gear here and reset position, zero it out on the world, and we're going to do that on the plane as well. And that way everything's kind of cleanly zeroed out. We'll move our light up. This light will probably most likely in this scene reflect a moon or something like that. So the light we want it to cast will also be an evening type hue. And if you look in movies, you'll see this trick in movies a lot. So it might be midnight out in a movie with no light sources around any of the characters or buildings, but everything's going to look really illuminated in this deep bluish purple. And it's just because you can't show the characters or tell a story in complete darkness, so they have to kind of fake a bit of the light. So you just go to taste on something you think looks, believable. I'm going to undock this. Wow. I'm going to undock this game window and just kind of bring it down so we can show what our camera's showing. And I'm, somewhat okay with the way that looks. So we've created our material for the ground. We've created or just used the directional light that's going to represent the moon or whatever, or the evening light source. And then, so the next thing we will create is an audio source that we need in the background, which is going to represent this looping rain sound. So what we can do is just drag and drop the rain loop in here, and it'll automatically create the audio source for that. And it'll even keep the name. So what we'll want to do is just click loop on that. And now if you hit play, you have a really nice ambient looping rain sound, but no rain to speak of going on in the scene. So what we want to do is go into those effect examples that we downloaded into Water Effects, and then prefabs the rain effect, and drag that into our scene. And it also needs to be, click on this little gear, cleanly zeroed out. So what the particles are doing, what this green thing looks like, this is just a piece of collision geometry. So as you can see, by default, it's not quite clean. It's got a little bit of, and this is how Unity brings it in, right? That's not very good, right? Hit apply, we'll fix that. And that just kind of zeroed and cleaned it out. What this is the collision mesh that the particles, when they fall down onto it, this is what they'll collide with. So if you have like a terrain or something like that, use the collision from that terrain or your world that you want the rain to fall on. So now when we go and try this out and we hit play, you'll see what I'm describing. So the rain is hitting, and honestly, the ground plane needs to kind of come up a little maybe. Yeah, when it's below, you can't see the little splashes taking place. So we'll just go 0.1 and Y, move it up just a hair above the ground. I'm going to select our camera so we can kind of see better what's going on in the scene. We'll go 25 with that. We'll go 6 with that. And this way we can better see what's going on. I made these changes while we're in play mode, but if you click this gear and go copy component, and we leave play mode, and then we go paste component values, it will move it to where we adjusted in the play mode. So now we have a looping rain sound, and we have a convincing rain effect. My only critique of this is rain doesn't just fall in one little tiny section like this. So let's click on the actual root particle system here, and we'll go down to the shape, and we'll see why it's only going in that small circle. So it's the radius, and we'll just expand that radius out. I feel like a value of 12 is probably good for these purposes, but in your game, if you want rain to cover everywhere, you just go bigger with that, and then you'd go in here and tweak your particles so that you're kind of throwing down more rain. So we'll go in here and we're good to go. So at this point, what we might need to do is we need the light source that's going to represent our lightning bolt. And what you'll want to do here is go to game object light and create a directional light. And then we will just reset this entire thing. We'll move it up a little bit. Let's move it up, and then we'll rotate it maybe 60 degrees like that. And we will change it to a color that just I might think that a lightning flash would be, and I feel like they look almost like a neon purplish green sometimes. And again, this is just going to be what you think it looks like. Yeah. We don't really have to worry about the intensity because the script is actually going to control that. But we, I mean, that's how bright it's going to look when our lightning hits. So we'll have to think about that. And then we will type, not lighting, we will type lightning. And then we can disable it because by default we want our lightning bolt to be disabled. So we can go in here and start creating our script for the lightning manager. And this is a really simple script. It's literally about 50 lines of code. So we're going to right click in our project area and go create C# script, and we'll call this, we could call it our lightning manager, but it doesn't really matter. And then what we'll do is you could just create an empty game object in the scene and call it your lightning manager, but I'm just going to drag and drop it onto the actual light. And we will double click this script, and we're going to go in here and kind of write it up real quick. I'm going to zoom in here so you guys can see what's going on. I'm going to kind of remove these code comments here. And what we're going to do is just start creating some variables in this script, which are just going to be sort of containers for data or information, and they're going to be public, so they will literally be slots over here that you can drag and drop the components you want to reference in the Unity inspector. So the very first thing is we want this to be adjustable in the inspector, so we will call it public, so it'll be exposed publicly in the inspector. It's going to be a type of float, so it's going to be a decimal point floating number, and we're going to call it off minimum, and we'll just say it has a default value of 10 to start, and we put that F at the end to basically designate this as a type of float, even though we are definitely declaring that this is a type of float. It's just good practice to do that, and I believe Unity might complain. So we need another public float, and we're going to say off max, and we'll just say 60F, which would represent 1 minute. So at this point we would say it's going to stay off for 10 seconds at a minimum, because we're going to randomly turn it on and off, and then at a maximum it can stay off. The lightning won't be turning on or crashing for up to a minute. So the next thing we want to do is another public float, and we will call this on min, and we'll say 0.25F, so 1/4 of a second, and then another public float, and we'll call it off max, and we will say that that is, like 1/8 of a second. And what this is the physical light in Unity. This is how we're going to determine when it's turned on and active, how long does it actually flicker and flash for at a minimum and a maximum. So we need a reference to the actual light that's going to be our lightning. We want it to be public, so we want it exposed in the inspector, so it's going to be a type of light, and we'll just call it a light. And then public audio clip, and this is going to be an array of audio clips. So what we want to do is use these two brackets on the keyboard, and we're going to just call this the thunder sounds. These are going to be all of the audio clips that are the crashes of thunder and lightning when the light comes on. And then we want to reference the audio source that's going to play those thunder sounds, and we can just call this audio source. And that right there is going to do it for all of the variables that we need. Off max. Oh, this is not off. This is the minimum amount of time it's going to stay on and the maximum amount of time it's going to stay on. I'm sorry I didn't explain that properly before. So, okay, we have our public light reference, we have that. So let's go into when we start the scene. So when the scene starts up and you hit the play button, we want to start a coroutine. So what that's going to do is just keep repeating this function over and over and over. And we'll just call the coroutine lightning. And we won't delay it or anything like that. We could pass in another value here and kind of delay that coroutine start, so it wouldn't start right away when the scene starts. So if you don't want your lightning to start kicking off right away, put a value in of like 5 seconds, and then it will start the coroutine to start the lightning 5 seconds after the scene starts. But for our purposes, let's just start it immediately. We're not going to be doing update because that occurs every frame, and we kind of want to control it through a coroutine, which is happening in a timed interval that we want to determine. And a coroutine is used by using an IE numerator, and it needs to match the coroutine name that we're calling up here. Okay, so we'll give ourselves a couple of returns in there. And so what we want to do is just a little while loop, and so the while loop will just have us keep repeating this and repeating this while it's true, right? So we'll say while true, which just means while this has this been called in start, while this is occurring, just continue to do it. So it won't occur when the scene is stopped and we're not working on it. Why is this? Maybe there's a spelling error in there. I'll copy and paste this over. Yeah, we'll look at that later. Okay, so while true, what we want to do is yield, return new, and wait for seconds. And then we're going to say random dot range, and then we're going to use that off min, and then that off max, and kind of close this out with the semicolon. And then we're going to say light enabled equals true. So what this says, while we go down here into this coroutine, and while it's true and happening, let's yield, and basically the yield return new wait for seconds is just a, hey, hold up and wait this amount of time before we do this thing right under the yield statement, which is let's turn the light on, let's enable it, because by default that light is disabled right here, and it's going to turn that checkbox on and turn the light on. And we use the built-in functionality of random range to randomly give us a value between our off time and our max. So we randomly find the minimum and the max, those two values, to determine when the light comes on. And it gives it sort of a natural, more random effect. So within this coroutine, we want to start another coroutine, and we want to time when that happens. That's why we're going to do that. And we will call this coroutine play the sound effects. Oh, yep. That's not going to work. It's important how you get the syntax going. And So it's going to run down and do that coroutine, but we're also in this coroutine, we're going to yield return new wait for seconds, and we're going to do random range. We could probably copy that line above if you really want to be faster. I'm not the fastest typist, and so we want to come down to this and yield too many returns, and then we want to say light enabled equals false. So this is, once this coroutine has enabled the light, this one shoots down, this embedded coroutine will shoot down here and call this other coroutine that's going to work on the sound effects, and then it's going to pass over that when that's been worked out. And then we're going to yield again just for a little bit. This is when the light is on. So we're saying this timing for when the light has been enabled and is on, how long do we want it to stay on? So let's randomly say the on minimum time, the on maximum time, and then we turn it off after that time. So this gives us a sort of natural random feel for how long that light is flashing and on. Okay? And that right there is the first coroutine. We need to do this coroutine here, which is the sound effects. So I am going to just copy this, Control C and Control V, and we're going to call this one sound effects. Okay. And then in sound effects, we want it to, and because I don't want to keep typing all this out, we're going to copy that yield wait for seconds, and we're going to put in some values for the sound hard-coded, and it's going to use a random range between these two values, 1.75, and I found these values worked good. So what we're going to do is it's going to say hold up, don't do anything with the audio yet. Then it's going to grab that audio source reference that we declared right here publicly, and you're going to drag and drop the audio source into that slot. It's going to use that reference, and it's going to use a built-in functionality of the audio source called play one shot. It's going to go into Thunder Sounds, and I'm going to type some stuff here, and then I'll explain it in a moment. Okay. And so I need to take a good look at this and see where my syntax is clearly wrong. I'm going to hit save. We'll go back to Unity, and we will see. Oh, okay. Yeah, we can't use the same designation as the class. Sorry about that. So we will call this lightning effects and hit Control S to save it. We will go back to Unity and take a look at our other error. Cannot implicitly convert type float to int. Okay, yes. So the array of audio sources are integers. I put the F behind it, so it thought this array were floats. They're not floating values. They're literally on and off 1 or 0 slots. I'm going to remove this here. So basically what we said is when we call this coroutine sound effects, go down here, hold up for this amount of seconds, which is going to be this random range between 1/4 of a second and then almost 2 seconds. Then we're going to take the reference to that audio source. We're going to play one shot from this array of audio clips. This is designated as an array because of these brackets. From within that array, pick a random range, which is going to be an item out of that array randomly from the 0 location, which is the very first object in that array, to its entire length, however many amount of sound clips you have in your array. So this code is done. We're going to go back to Unity. Our errors will clear out. And so now our Lightning script has propagated, and you see by declaring these public variables, we can go in here and adjust them. If I take offmin and I make it private, this is just a little bit of code stuff, hit save, go back, this will disappear and won't be adjustable in the inspector. And the only place you'll be able to adjust this will be in the code. You may ask, why does someone want to do something like that? Why not? Unity makes life easy. It's because when you're working on a team and you want to hand this prefab with the script off to a team of designers, and say you have a variable that you just don't, as the engineer or coder on the project, you don't want an artist or a designer to go in here and change values for something because you have a hard-coded value, very similar to our the amount of delay we have for the audio sounds. You don't want them changing that, so you privatize it. So what we have here is the Lightning Manager. I'm going to say the amount of time I want the light the minimum amount of time I want between the thunder and lightning going off would be like 4 seconds. And the maximum amount of time, excuse me, would be 15. And that's how long it's going to be maximum between lightning crashes and the minimum amount of time. How long do I want the light on? I'm going to leave it at 1/4 of a second and then, an 1/8 of a second there. So what we could have done in here for this public light is, instead of making it something we drag and drop the light in, because it is applied to the light itself, it would know that the light's there. So we could just in start we could type in get component light, and it would automatically grab a reference to that light. But in this instance, we're dragging and dropping it. So I have 2 lightning crash sounds, so I can type 2 in here and then manually drag them in, or I can click this, hit the little lock icon, it'll hold, no matter whatever else I select, it'll hold that lightning script there, shift select these, and drag them into the array, and they're automatically propagated, and then unlock. And now we can go back. It's a neat little trick. If you have 50 different sounds, that's a real time saver. I only have 2, so I wouldn't have mind manually setting the array. This is the 0 element in the array. This is the element 1. So our audio source, we need to add a component for that. So we can type in here, look down, find audio source, or we can go up into components, audio, and you can add an audio source there. We don't need to mess with any other setting. The audio source, what will occur is this script will take the lightning crashes and automatically assign it as a clip into there. We don't manually assign it in because the script is going to randomly pick from all the clips you provided and insert them in here dynamically. So let's just test this right now and hit play. We have the looping raining sound. We shouldn't wait more than 4 seconds. And we have a null reference. Because even on this lightning script, another thing we might have wanted to do was for this audio source also get the component, because the component's right here. But because we didn't do a get component, we do have to manually drag it in there. So let's hit play. And for the purposes of this tutorial, I could have made these times between the crashes smaller, but and there it is. Okay, and you'll notice something neat. There was a delay from when the light struck to when you heard the sound. And that's how lightning usually works. There is a bit of a delay unless it's right on top of you, and that's just creepy, and I wouldn't want to do that to a player in a game. But that's what this start coroutine here is. Because otherwise we could have just played the audio up here in this coroutine, but we wanted to sort of put a little delay. And this right here is that delay of the sound, and we use a random time. So 0.25 seconds, 1/4 of a second would mean that lightning was really close to the player. And then almost 2 seconds later would mean, well, that lightning was a bit off in the distance. You could even go as far as coding in here a volume based on whatever this value, what that was randomly found, and tweaking the volume level of that thunder. For testing purposes, I'm going to really decrease our lightning to every minimum of 2 seconds, maximum of 6. Okay, so it comes on, comes on again, another crash, different crash. So for the purposes of this tutorial, that would be done. But the reason I included the Flickering Light script without actually typing it up and showing you how it works is it's sort of really polish on the lightning, because the lightning looks like a light that's just coming on and turning off, and it doesn't look very good. So I had a tutorial right here on one of my other YouTube channels called Creating Flickering Light Sources in Unity. And in this tutorial, I create this script, and I believe we use it to create a flickering candle light. So this script has usages well beyond just creating a lightning effect. But again, the code is down in the video description. So what we're going to do is I'm going to take that lightning light and we're going to drag flickering light on top of it. Okay? What we're going to want to use for this is just a noise function. All of these are different, really cool. Experiment with them and use them for stuff like flickering street lights or candle flickers. So the base start on this will be the value that the light starts off with by default. We start off with an intensity of 0.7, so we can just say 0.75. The amplitude is how high up in intensity that light will go when it's flickering, and we'll just say 0.6 because we don't want to blow it out. We don't have to worry about the phase or the frequency. Those are really, really fine tuning it. But you'll see the difference when the light comes on now. And what the flickering light source is it's just, so now you see the effect we get. And it just really adds a polish to that lightning and makes it really realistic. So I believe if we go down here and change that starting base amplitude on it, it should start out much more subdued. Yeah, it's not nearly as bright as before. And then you can go in here and it starts with the default base color of your light. So if you want to be crazy and you're on an alien planet and you have lightning that looks orange or red. Yes, I've used this flickering light code on police lights as well, and it works really good. So I hope that gets you guys going in creating lightning in your gaming projects, and all of this stuff that we put in here to get this going is free from Unity and open source and free from freesound.org. And then there's also this tutorial if you want to really see how to do candlelight, stars, muzzle flashes, even blinking traffic lights. That flickering light script is really handy. And again, I'm going to put it in the video description. If you have any questions or any feedback for me, please feel free to comment them down in the video comments. Thank you for watching, and I look forward to the next tutorial.